Okay, great. So we'll just quick start the session. So today we're going to do a search AMA. So Elastic, after the current situation, we have taken off a lot of events uh, in real life to virtual. But we've been doing these sort of sessions in APAC for quite some time, and we have a virtual user group. For all the events, you can definitely come back to community.elastic.co and find your chapter, and you could sign up so that you would get the information about all the latest events that are happening. So there are webinars that we are doing, AMAs like these, and also many other sessions that improve your Elastic Stack knowledge, take questions, and we are also collecting feedback from you about what you are looking to learn or see more from us. That being said, if you want to speak at one of these, we are very happy to like you can come and present at this chapter as well. Today we have Alex and David. So Alex and David are developer advocates just like me, but based in EMEA, like the Europe region. So they are search specific advocates. They have done quite a bit of work in search area. And both of them have worked in Elasticsearch teams, and they have quite a bit of experience working with search engines and tuning them at a large scale. So yeah, so we'll quickly start the session. So I believe David and Alex all set, right?
Yes, we are. Hello, everybody. Welcome.
So yeah, and also like you can ask live questions. We'll take the questions from the doc, but also if you want to ask any question to us, we are happy to help. And yeah, so we'll take questions from you as well. So the first question, I think I'll cherry pick a questions and probably like David and Alex can also answer. So so yeah, this sounds very abstract. So what is search for you? So anyone can pick, like David.
Yeah, or maybe we can have a debate with Alexander actually about what is search. So to me, yeah, search is something that I discovered when I was working in my previous company at the French Customs. And I thought I was doing search because I was using a database to search for my data. And I was doing SQL things, and I thought I was doing search. But then I discovered Elasticsearch, and I started to realize that actually search is not really like that. It's not select star from a table where x equal xyz, I don't know. And it was totally different things. And I started to think about search differently, like Google, actually. If you are using a search engine like Google, what you expect to have is the more relevant information on the top of your list. Not all the elements. You don't need everything. You don't need to go through all pages, for example, to find the information that you want to have. But as the developer, you want to simplify the access to the right data for the user. And search, to me, is really different from what I used to implement in the past. So I was more considering what is the user need for my application, what is more important, I mean, in terms of columns, for example, if you think about tables in a SQL database, like which columns are more important than the other ones. So what are the boost factor that I want to put in a search query to make sure that the best result appears first instead of at the end of the list. So search is something like fuzzy, right? You can have you can deal with typos, you can deal with a lot of things. So it's a capability to find the right information for you in tons, in millions of billions of data, for example. That's how I see search. Alex?
Yeah,
Do you agree?
so absolutely not, as usual. No, just kidding. Yeah, when I started with Elasticsearch, I was working at an e-commerce company, which was basically kind of a marketplace. So we were the platform had buyers, sellers, and we were searching for a product search engine. And I figured out that it's pretty easy to get up and running with Elasticsearch. A couple of years later, I joined Elastic, and I was always sure that Elastic and Elasticsearch and search in general was like the classic full text search, retrieving data from our data set. And there was a German language-based search engine. So we had all the specialties with really long German compound words in there and dealt with that, and lots of synonyms. And I thought, like, this is search, right? Like, this is how I get it right. And then I joined Elastic. And on the first day I talked to Shai, and he basically told me, look, like 40% of our users are coming from the log-based search. So they were ingesting log files, and I hadn't even thought about this use case back then. I was just super surprised that a ton of users were there, like not using full text search engine for full text search. And so at that from that point in time, I figured out that search is something very, very generic, and it's not about like the data you index or anything like that. It's more about the ability to ask certain questions, and maybe having the ability to ask questions which are centered around full text search, like taking stemming into account, synonym, these kind of things. But if you don't need this and you just need to aggregate a lot of data and do this really fast, this is also search. And at that point in time, I kind of clarified for me what search really is. It's really about efficient and fast information retrieval of the questions you have. And that's search for me up to date.
Interesting. So for all of you, like when you started, is Elasticsearch your default choice, or like you have evaluated trying to do search plugins on top of your regular MySQL or RDBMS systems?
So, sorry, can you repeat the question, please?
No, I was just asking, like, is Elasticsearch your default choice, or like you really found out Elasticsearch to be the search engine, or you try to add a search extension for PostgreSQL or MySQL that you have?
Okay, so yeah, so when I was working at the French Customs, the first thing I tried to do was to add, I was doing Java code, and I was using Hibernate at this period of time, and I was trying to add the Hibernate search, which is still using Lucene behind the scene in my project. But then I realized that actually my application was split into two different servers, and unfortunately the Lucene indices were local to the web server where my application was running. So anytime I was switching from one web app server to the other one, I was able to see only half of the indices, which was not working. And I ended up finding a solution. I was trying to find a solution and implementing myself, storing Lucene indices in the database, which is a very bad idea, by the way. And then I realized that someone wrote a project named Compass, and he was telling to the users that the future of Compass is Elasticsearch. And then I started to check this project, and I just started it, and it totally blew my mind. I mean, I was not able to sleep for one full week because I realized that someone in his garage or wherever alone build a so powerful thing that can be spread on multiple servers, that can serve search in a real easy way. And then I started to realize that actually I can do more than search, as Alex said. So the first step for me was then, okay, how I can connect the two worlds, because I have a world of with a database, a normal database where I send documents in the database, and I need to take this information and send that to the search engine that I want to use, which was Elasticsearch at this moment. And to do this, the first thing I did was to read again the database every 5 minutes or so, maybe more than that, and try to transform all my entities that I had to JSON documents. But I realized that actually it was taking a lot of time, it was consuming a lot of time in the database itself, because I had to do a lot of joins. My data model was super complex, and I have a lot of data spread over multiple tables, so I had to do a lot of joins. And then I realized that if I want to ingest my full database, it will take like maybe 6 hours, 10 hours, I don't know exactly, to read the database. So I cannot do that every 5 minutes. It does not work. So I started to think about that in another way. I was thinking that actually I have all my information that I need in the memory somewhere in my Java application. And anytime I'm saving using Hibernate my entity inside the database with Hibernate, in the same transaction, I can just transform that entity, that bin, to actually a JSON document. It's only one line of code. And in another line of code, I can just throw that JSON document to Elasticsearch. And then I started to realize that actually it's super easy to connect both worlds. And that's how I ended up connecting the both systems. And I was super happy with that solution.
Great. So I think we'll quickly go on to the next question. So now continuing the same conversation, like how do you build a search engine with Elastic Stack? So when I believe like this is more often like, I know that Elasticsearch is a distributed system, and then you could definitely build on any system. What is the best way to build a search engine today? Like what do you think, Alex? Is it using VMs or how?
I think like everything starts with the data, and David already hinted at that. Like if you have a primary data store like a SQL database, your main thoughts usually revolve around how to get my data from my primary data source without overloading it. I had the same problem with my former company, that it took joins of 22 tables to get all the data that we actually needed. And like the first thing is to get the right data, get everything into a single document, and then put this into Elasticsearch and go from there. But this is only like the first really tiny step, despite it looks big. But the interesting part of search is not like having something like SQL where you say, search something that is exactly where fields is exactly like this, but the interesting power is search. So this also means that you basically have to take the time to sit down and understand how search is really working, how search is working in a distributed system, how search is working on a non-distributed system, just the general concepts, like how is data stored in an inverted index. And once you understand this, you also understand how queries are formulated, why queries are slow, why queries are fast, how you can optimize at certain stages. And I think this is, despite a kind of different way of thinking how data is stored, still all the fundamentals to get started. And I find this crazily important, because if you screw up things at the beginning and you store data not the wrong way, but a different way that makes your queries inefficient, it's super hard to fix this later in your application or at query time. So sitting down, understanding first your data, and second, how queries and all of these data structures work, because they are different than a database-driven index, is super important. And once you do have this, that's the point where you basically go a step higher and integrate all of this in your application, like having this famous Google-like search bar in your e-commerce app that answers all your questions and go from there.
So yeah, I want to add a few things. So when I came to the search engine model, I stopped thinking about the current way I design my data, and I start to think in another way. As an end user, what I'm searching for, what kind of entities I'm searching for. Even though I have, I don't know, a product table and a company table, if the question is, I want to search for products, then the only thing I want to index is actually products. I don't need to index products and companies, for example. But if I need to search, then the second question I have to ask myself is, what are the elements I need to query my data set? So if I need the company name, which is connected to a product, then I need to put the company inside the product. So I started to think in another way than we used to think the search when we were using a SQL database. So those are the most important questions for me, what I'm searching for and what I need to search for this data. Then the second thing I would like to add is about Elasticstack and how you build a search engine with Elasticstack. So you can, of course, use Elasticsearch, but you might be aware that we released a new product named AppSearch, which is running on top of Elasticsearch. And this AppSearch is going to simplify a lot the development that you have to do yourself. If you want to just implement, and not that just implement because it's more than that, but if you want to implement, for example, a search bar, like Alex said, with auto-completion and dealing with typos, without the need of building all the queries by yourself, all the model by yourself, and all that thing, you just basically throw your data to the AppSearch service that you can run yourself, or better to run it on our cloud services. And then you just have a UI, you have a UI where you can play with the mapping, you can update the mapping on the fly and things along those lines, which is kind of tricky if you do that yourself with Elasticsearch. So there are two ways of implementing a search engine with Elasticstack. There is another way as well, which is workplace search. If you want to build a search engine on your company documents, for example, and you want to crawl the data coming from Google Drive, for example, or GitHub, or multiple data sources, then you have a out-of-the-box tool which is ready for you. So it depends on the needs. If you want to be super flexible and do whatever you want, then yes, go with Elasticsearch. If you have you want to do restaurant recommendation engine, for example, probably AppSearch will be enough to cover all the needs. I think that Yelp, for example, the application is using AppSearch behind the scene to power its search. So it really depends on the need that you have. You can use the stack and different tools in the stack to build a search engine.
We do have some questions coming in from the chat. So I think we'll take one question. Like, I think one thing that you mentioned here, David, like what is AppSearch? There's one question related to that, like what should be the best use case to start Elasticstack as a student? So if you ask me as a student, what's the best use case? Like search could be a very interesting and good use case when you compare with log analytics or other use cases, because it's more relevant, and probably you could ingest some movie data and like try to search the movie labels or whatever the songs or latest things. So think of building a search engine for someone like Spotify, right? So these are the common things that you probably might be using. And like David said, AppSearch is a wonderful way to kickstart things, and you would probably like get started very easily. Like that is more easier to get started.
Yeah, I want to add something again. Sorry, I'm
Yeah.
I'm speaking a lot. If you start the stack, I mean Elasticsearch and Kibana, then in Kibana you have a way to import sample data which are already available, and like you have an e-commerce website example, and so it could be super useful if you don't have the data yourself and you don't know how to ingest the data first and you want to play with the stack. Just start Elasticsearch, start Kibana, click on the import the e-commerce sample data, and then you can start to play with that. I think it would be a good way to start with the stack.
Yeah, we have I think 3 or 4 sample data sets, and like we keep adding them, different dashboards and different ways
yes,
for everything. Yeah, good. So I think like, yeah, to balance out, like this one we'll give it to Alex, and like we'll see we can ask him more questions. So there's another question, right? Can Elasticsearch be used to find duplicates or near duplicates in binary data? For example, there are 100K photos on Elasticsearch, be used to find duplicates. Okay, this is more of like search.
Yeah, that's a kind of a mix between search and non-search, mainly because it's binary data. So standard or by default, Elasticsearch only supports like text-based or other kind of text-based data like numbers, because you feed JSON into it. And there's a bigger but to this, and this requires me to add a little bit of context. Since Elasticsearch 7.2, there's a new data type, which is called the vector data type, which allows you to store an array of features, if you want, next to a document. So how this would work is basically that you add a set of features before storing the document, which also means you need to have some sort of feature extraction. The most common one for images usually is the color and the position of the colors. And then when you execute a query, you could just have a sort of reference picture, which contains the exact same vectors as part of the query, and say, show me photos that are similar to this photos, which have a similar vector. And this way, you could do something like that within Elasticsearch. The data type is called a sparse vector, and the way you would write the query would be part of the so-called script score query. But this still means that you would have to come up with the features yourself. There's some plans which are not yet really far to have this kind of functionality built into the stack, but this is still in the works, basically.
Okay, so I think there's an extension that to this, like even machine learning or using some sort of models to take it forward, right, Alex?
Yes.
Okay, good. So we have another question from Abhilash. So it says like, I had a taxonomy which spanned for 4 million words. The corresponding synonyms .txt would be around 1.3 GB. That's a lot. My question here is, one, is the synonyms.txt stored in each shard, or is the property of an index? Due to a lot of query expansions, how do you handle semantic search in general?
Yeah, that's another question that takes a little bit longer to add some context. So first, 4 million words and 1.3 gigabytes of synonyms is a lot, but I understand that there is a need for it. So the first thing is you store the synonyms txt on each node. However, and I think that still holds, I'm not 100% sure, for each index or each shard, this data is loaded into memory. I think at some point we deduplicated this, which means it's only loaded once per node into memory. And also the representation of this text file is a little bit different. It's not the text file as is, but it's basically already converted to another internal data structure that is much more efficient and deals with has the synonyms provided in the right order. It's called an FST. It's basically also what is used when you use the completion suggester. So the memory amount of memory required may actually be lower than what your original file is, but that depends a little bit on the data. But this is just the sort of technical implementation there. The other part is, I think, more interesting due to the lot of query expansions. How do you handle semantic search in general? And then the question there is, should you do the synonym expansion and contraction as part of your query? Or should you do some sort of query processing upfront to change how you query? Like, I'm not sure what you use the synonyms for like kind of extraction of certain terms and putting them, or like if this is the use case, maybe you could just change the fields where you query and so reduce the amount of data that you query, and it also have this data stored in the document itself instead of storing them in memory and expand them on index time. Maybe you can do this on query time. This, however, requires pre-processing of the documents. And that means that you have to have some sort of engine which takes a look at the document's context, decides, okay, this is where the synonyms should be applied. This is where the semantic part comes, and extract these kind of features into dedicated fields and then go from there. Again, this depends on the exact use case, so it's hard to tell. But that might be an idea to also try to reduce the amount of memory that you actually require for the taxonomies and synonyms to be stored. And this also means that you have this kind of logic on the query side as well, where you have to have your own kind of query parser that says like, look, this part should be moved into this field and this part of the query should be moved into that field. Very easy use case is usually e-commerce. If someone searches for a Nike hoodie, red XL, you as a human immediately know that Nike is a brand, red is a color, XL is a size, and move everything accordingly. Like this is the most simple way, but even this already requires you to have a custom query parser, which most implementations basically do on their own on their side. Of course, you can always work around that with things like the multi-match query, but if you really want to go the route of like being more exact, you usually are bound to write your own query parser. Again, there are a couple of ideas to use our machine learning implementation to do a lot of this automatically, but this is still a lot of research and development work going on.
Great. So I just have a follow-up question. Like, I think at some point they were like, if you want to change the synonym file in Elasticsearch, you need to restart each node, or need the details need to be calculated to everywhere. Now I think we have a dynamic synonym updater kind of a feature, right? To which we can dynamically update the synonyms, even.
Yes.
Okay. So that is a bit easier than the older times, I believe.
Yeah, there's an analyzer reload API. I think this is what it's called, which allows you to do that.
Okay, that's great. That's great. So yeah, going ahead, I think we'll take something down as well. Okay, this might be very relevant to whatever we are discussing. How can I use Elasticsearch to find near duplicates? Let's say I have two contacts with names, phone numbers, Mahita, and so, and then like, how do I want to report these sets of near duplicates? Yeah, I could find an option for fuzzy in-term aggregations. Finding duplicates by just phone number is not in my use case.
Yeah, I think this again boils down to one of the fundamentals of search, that you have two ways to decide how you want to search for that data. The one way is, like in this example, that you try to do things at query time. Right? You try to find nearby terms at query time and then also find a fancy way to aggregate those if you need to. But this means that you always need more time, because doing something at query time that could have been done at index time means you need to do something for each hit or for each document within an index. And the other thing you can do is do something at query time, which may be more expensive when you index documents, which may need more space on disk because it creates additional data structures. But it still means that your query is more efficient. So just like with SQL, you can decide, should you optimize for the write use case or read use case? Like in SQL, we are all trained to normalize our data to death, which is a great feature to prevent duplication of data. But the moment you need performance and you need to join your data, like I did at my former company over 22 tables, performance just goes nuts and it's going to be super slow. And the same applies to this principle. You could try to sort of find a fancy way, like a fuzzy query to find Mahita with the CH and without the H in there at query time. Or you could do something like phonetic analysis, which stores these two names probably in a very similar way in the inverted index. So they're different encoders, as they're called in Elasticsearch and Lucene. So phonetic search would be something like SoundX, which most people know from SQL, where you basically change the representation. For example, you remove vowels in there, and it's very likely that these two terms are similar. And there are different kinds of those encoders. Another implementation, for example, is for German surnames, which is used in a social network in Germany. There's also a specific one package with Elasticsearch and Lucene for New Zealand surnames, which there's not a lot of uses for except on New Zealand, but you get the idea. And they basically store another representation, which can be number-based or letter-based, depending on this kind of encoder, and they would store those two terms in a similar way. And these could be used to actually search and get duplicates in there. So that would be a possible way to tackle this. The way this is called is Phonetic Search, and you need to install an additional plugin that is part of Elasticsearch in order to do this. Let me quickly come up with a link. It's this one. And using this, you can basically try and figure out how these data like Mahita without TH and with TH are stored, and then go from there. Again, it requires your way of thinking, right? You usually tend to think of near duplicates as of I'm going to do this as query time, but the way that this plugin is doing it is storing these terms in a different representation at index time, and thus finding the connections when you execute the query. And I think this is what just requires some time with search in general to wrap your head around different concepts.
And while we are at it, because you are mentioning, Alex, that we do that at index time, maybe if the use case is to detect super early that there are duplicates in the system, maybe you want to be alerted as soon as you insert the new data that it's actually a duplicate of another one. So maybe you can compute a fingerprint of the two things that you have, the phonetic representation of the name and the phone number, and compute a fingerprint of those two fields, and then use this fingerprint as the ID of the document. And then ask Elasticsearch to reject any update for a document, which means that as soon as you are going to insert a document which is close to the previous one, maybe you will end up to send an exception to the user saying, okay, I found a duplicate, so I cannot insert this new data. It depends on the use case, of course, and the way you can implement that. I'm not sure, by the way, that we can use the phonetic plugin in that way. I said, no, I don't think we can call it. And to generate the fingerprint with this, it would be more complex than that. Actually, and we cannot create a fingerprint using the ingest nodes. But if we do that using an ETL tool, we can maybe call the analyzer endpoint and try to analyze the text, which is going to give the phonetic representation of the text, and then combine the two things and compute a fingerprint and use this fingerprint as the ID. So maybe it can work in another way. Anyway, that was a way to say that you can also reject the data if this is your use case at index time, instead of trying to find duplicates later at search time.
Great. So moving on to the next question, I think we have something similar in the same, synonyms analyzer space. So there was one question related to, like, does Elastic have similar city management, like say Bangalore and Bangalore are the same? Similarly, you have similar names for like which are synonyms actually, but do we have rather than people adding it, do we have a way to automatically identify it?
Yeah, I can take that one. So there's currently no way to sort of automatically identify it. As you can see here, Mumbai and Bombay and Bangalore and Bangalore are very different in terms of writing. So something like the phonetic analyzers wouldn't help us here. Something like a fuzzy search would not help us here. But I think the basic idea here would probably be that either you maintain this list of synonyms and add them at search time. Another idea that I could possibly have is if you have a list of those synonyms, there's a more recent feature in Elasticsearch, which is called the Enrich Processor. Let me quickly find that one and paste the link over in here. And that's part of the so-called ingest node. The ingest node allows you to modify the JSON that you have before you index it. And the Enrich Processor allows you to execute a search, take the results from the search and put them into the document before it gets basically stored, or enrich the JSON with that. And if you do have a list of cities that you probably maintain yourself because it's more exact, and maybe you have different dialects on a region or what have you, or per country, then you could do this enrichment on index time and even see this within the document. So instead of having a city which is just named with one name, you could just store both names there. And you could use synonyms for that, but synonyms means that the user or the person indexing your data into Elasticsearch would also have to understand the whole mapping part of things, would need to be able to change and configure the mapping, where the Enrich Processor only requires you to add another document to an index, which is something that the user probably is used to do, and then have one more alias for a certain city in there. So that might actually help you to do that. But again, there's no automatic way that there's a special implementation for Elasticsearch, which just has a fancy list of cities which are used for this kind of enrichment. So you have to bring the data, and we can just bring the mechanisms to enrich your document the way you would like them to be.
So would that answer also, by the way, the 15 question that we had about the taxonomy and the fact that we were storing a synonym file on all the shards? Maybe using the Enrich processor, you can solve also this use case, and instead of loading the memory as we mentioned before.
If you are able to extract the information beforehand, which is much harder on text-based documents than just having a field which contains the city, right? That's the main difference, at least how I understood it. But if the asking person is in here, feel free to correct me on that one.
Okay, good. So we have two similar questions here. It is like about how do I come up to a size in the cluster? Wherein like say, what are the minimum requirements if you want to set up Elasticsearch for an application log? This is more of like, you know, not search, but more into, I believe, like log. When the person asked, it's probably the logs actually. And then we also have, how do we determine the disk size, cluster size for a specific set of data? For example, I have 100 GB of data. How do I determine nodes, RAM, disk space needed for this? So yeah, both are like sizing related questions. And
so let me take this one. Because the answer is super easy. So it depends. I'm done. Okay. No, so this is a common question that we are seeing a lot of time on the mailing list. Like, I have 100 GB of data, and how many nodes do I need, and blah, and what have you. So it really depends on the use case. If you are thinking about logs, it's totally a different use case, and the way your users are interacting with the data is totally different, because you are going to query the most recent data instead of querying all the time all the data set. If you have 100 of gigabytes of text, like books, for example, then it's totally a different approach. You are going to do less frequent updates using less frequent updates if you are storing books than if you are inserting logs data. It means that you are going to index a lot of data every second, and so it's totally different. And based on that, you need to actually test your data set with typical nodes. And the first thing you have to do is to determine how many data you can hold in a shard before the response time or the index time is starting to fall. So the way you do that is by testing. You just prepare a scenario, a test, an ingest test and a search test. You can use for that Elastic Rally tool, which is super useful to play again and again the same data set. And you try to overload a shard with, I don't know, for example, for 100 GB of data, maybe you will need 2 shards to hold all the data. And then based on that, you have another question to answer, which is how many shards can I hold within the same node, within one physical node, with 4 GB of memory, for example, or 8 GB of memory. And once you have this information, you can start to compute actually how many memory you will need, how many nodes you will need, and also what is the disk space, obviously, because once you have indexed the source data, you will have the ratio depending on the use case. For example, if you are using n-grams, you are going in the analysis process, you are going to generate a lot of tokens, which means that you are going to produce much more data than the original data. So it really depends, and you have to test all that. I think, yeah, that's what I wanted to say. Alex, you want to add something?
No, nothing to add. Arraigned, you're muted in case you just not try to move your mouse.
Thank you, Romain, by the way, for adding the links. Thank you.
No, so I was just saying that there are a lot of things to take into consideration when we start sizing. I mean, like Elasticsearch for a specific use case. Say, of course, data and a lot of things that David has said. But also, it is very simple nowadays with managed service. Like you could just get started with Elastic managed service, and like it simply creates you a cluster, and probably it is very easy to ingest and try testing out and doing more things. So that looks very easy to me when compared with creating a cluster in EC2 and trying to bring up a lot of these things. Yeah. So, okay, so I have one more question with respect to the shards nodes, I think here. So yeah, do I have to create an index for multiple varying fields, but with small data sets? Let's say I have an index tracking some statistics or logs. I don't know what logs is. I would have only hundreds of records in this index, but creating an index would require a shard. If I have 10 or more utility indexes, all with different sets of fields like this, I'm wasting 10 shards just for 10,000 records.
I suppose that the logs with CK are probably logs with a G, and then it makes some more sense again. So in general, like this is not a lot of data, right? Like 10,000 records is usually something you can handle easily. However, there's a limit with the number of fields on a per index. So if each of those documents really has a lot of fields, and each of those different types of documents really have a very different number of fields, then you could probably run into this limit. I think it's 1,000 fields per index right now by default. If that's not the case, or if that is the case, you could even try to group them together if they are rather similar. So if you have two types of document that have roughly the same fields up to a certain percentage and then they don't, then group them together. If none of this works, you would indeed waste 10 shards, but that will probably be fine given the total number of data in there. But if you have the ability to group things together, it would probably be a little bit more efficient. If you just put everything into a single index, which would work given the number of documents, one of the side effects of how Lucene stores the data is that you end up with so-called sparse data, which means there's like one field in one document and then there's not in 10 or 100 others or something like that. And this just makes things like the compression of the index a little bit more inefficient compared to when every document had this data. Given the fact that we're talking about not a lot of documents, again, this is something I would not really be worrying about. My usual approach to this kind of problem is that I try to go with the easiest solution as possible at the beginning, and if I hit a limit or if anything goes wrong, then adapt to that. Given the fact here that you would only have 10 shards, you could do that, or you could go with 1 shard and see if it works given the field limit. But I would not overthink this. I would just start as easy as possible and as simple as possible and then go from there. I think the things to keep in mind is basically the field limit and how your data would look like if you, or how the number of space you actually need if you had millions of documents in there. And then I would start to adapt. For 10,000 documents, I just would not worry too much.
Okay.
I think that in this theme, we have the question number 3, which is kind of similar. Not exactly the same thing, but it's super close to this one. So maybe we should try to answer this one now.
What's the question number?
Number 3.
Number 3. Yeah. Okay. Yeah.
My accent. So see my fingers. 3.
Yes. We have multi-tenant. Okay, the next question is like, we have a multi-tenant platform for e-commerce where we like to store products and orders in Elastic. Tenants are to be 1,000 or more. So we are thinking to go with one index as routing key and routing key as tenant ID. Is that a good approach?
So that's a good question actually, and it resembles one of the very, very common cases that and also one of the common use cases with Elasticsearch, that you probably have a lot of data. So you need an index that is a certain number of shards. And maybe you also have one tenant that is exceptionally big compared to the, or one or two tenants, a couple of them, compared to all of the others. And the way this is called, and there are a couple of talks there, there's also mentioned in the ebook, The Definitive Guide, which despite its age is still really, really good at explaining the concepts. It's basically a book from O'Reilly that you can also read for free on Elasticsearch. And it's a so-called user-based data flow as compared to a time-based data flow where all the events actually evolve around time. And the user-based data flow says exactly that you can just start with one big index with a fair share of shards and use something called the routing key to index the document. Routing basically means that the ID of the tenant is used to decide which shard the document is placed on. You can't really say which shard exactly. The only thing you ensure with this approach is that all the documents by a single tenant are ending up in the same shard. So if you end up searching your data and you just want to get data from a single tenant, you would only need to query a single shard. And if you have dozens of them, the other ones would not be queried. So the search would be much more efficient. One of the things you have to pay attention with this approach is like the elephant problem. Like if there's one tenant having a massive amount of data, you end up with shards being sized very irregular and maybe also getting too big. But the interesting approach of this problem would be that you could just say, I want to have an own index of this tenant. And maybe this index should already have several shards by default. Just reindex your data and you're good with this. And you could use something called filtered aliases to actually use aliases instead of the index name to retrieve data from tenants. So for each of your tenants, you could have an index that basically allows you to just name the tenant name as the alias and just get data back. And then it doesn't really matter if you query this one single index with a lot of tenants in there, or if you query another index. You're basically hiding the concrete implementation, just like with an interface with an alias. Like the user himself should never care what he has to query. The user himself is just interested to retrieve the data that he actually wants to have. So yeah, going with this approach with a routing key and one index at the beginning, which can potentially be changed to a dedicated index for the elephants, is, from my perspective, actually a good approach. And it also allows you to query your whole data set completely independent from the tenants without problems.
Yeah, I remember also I spoke with a user once who wanted to implement a service for his users, and he wanted to implement a free tier, like for a minimal set of documents. And he was initially he was creating one index per tenant. And so I told him that maybe he can think about his business in another way. Like you have users who are going to pay you a huge amount of money to make their service run in a fast way, etc. And then with this approach, you can dedicate one index running on super fast machine because it's more expensive and blah, blah, blah. And you can have also, as Alex said, all the free tier going to one single index using, I don't know, some 10 shards, using slow disk and what have you. And using all those settings, you can implement that kind of business model as well.
Interesting. So yeah, but I also feel like in some cases when people think to use routing key as some unique number, do you also feel that there's a chances of data loss, like chances of like situation where people lose their routing key and try to route to a specific shard or a specific node? This I see very often, wherein like people lose data or people will not be able to manage it at large scale for millions if it goes that way. What do you think?
Yeah, one thing you can do is to configure the index that the user always has to provide the routing key, so you accidentally don't put documents on the wrong shards. But if you're using something as essential as the routing key, which would be the tenant ID here, I think that's more of an implementation problem than something to be afraid of data loss. It's a different thing. Like there's no need to be afraid of data loss in here. It's more like your application suddenly forgets how it's supposed to store data. And again, like test coverage and this failsafe within Elasticsearch that you always have to provide a routing ID when you add a document should usually be good enough.
Okay, good.
Yeah. Trust other features from other data stores. Like, don't reinvent things yourself. It's just a general really good recommendation, completely independent from where you store your data.
Okay, yeah, right. So I think there is one more question here wherein which talks about indexing, like reindexing and reindexing. So do I really have no option of removing a field from an index other than reindexing? I have an application which have objects and fields. I index to Elastic. The application often changes data types. Let's say field amount is incorrect, created as text. The data is indexed to Elastic. Now application realizes the mistake and changes field type as number. And when I index the data, now I get data type mismatch errors. What are the best way to handle such errors? Currently, we create a new field with field data type to handle such scenario.
Yeah, I think you have no other way than reindexing the data in another way. So there are multiple options for that. But it depends on really what you want to do. If you just want to remove this field from the mapping, then it means that you have to drop entirely the index and reindex everything. If you can just save the data, and if you want to do that, save the data to another field name, then you can do that. So, but you need to reindex all the data set, of course, because it's not going to work. What you can do is maybe to reindex the source data to another index using the right mapping, using the reindex API that we have. So it means that you are going to be able to read the existing data from the old index and send them to the new index. And if you need to do some data transformation, you can use what Alex already mentioned, the ingest nodes features, where you can transform the data on the fly and make sure that they appear in the right way. So that's a way to simplify the reindexation process, but you will end up reindexing your data, yes. Also adding a comment on that, you can also add aliases on fields now. So if by mistake you misspell a field name, for example, instead of reindexing everything, you can add a field alias instead of reindexing all the things, and then you will be able to query this alias if you need. So that's but that's another question.
Okay, I think there's some chat going on in the chat, but I think Alex answered the question. I'll quickly talk about one specific question here. David, are you looking at any other question other than that? Like, you're finished?
Say that again, sorry.
Okay, you finished to answer the question, right?
Yeah, I did. Yeah.
Yeah, great. So what are the best metrics to measure the success of a site search for e-commerce? I think this is more of like our app search analytics, and I mean, what are the metrics that we look for search?
Yeah, I think I can answer on that one because we pretty much failed to do that at my previous company, I would say. So how to measure the success of a search in general is super hard, but e-commerce isn't harder. I mean, in an e-commerce website, it ultimately boils down to the revenue you make. But this is just a really tiny part of an e-commerce site, right? You also have landing pages, which are very special, like optimized for this one experience. The most common thing in e-commerce is always conversion rate, like how many users from a website can I get to really buy something? But how do you combine this with search? Like, how do you say, like, this is a conversion rate which has changed because we did this search, right? This is super, super hard. And there are a couple of things you can do that. Of course, one of the things we did back then was like log every search request, right? One of the things we did every morning is sending out an email to a couple of people, like, these searches return 0 results. These are the top searches of the day from yesterday that didn't return any result, right? The worst thing in an e-commerce shop is, like, you search for something and you don't get anything. This means the buyer can't buy anything. It's kind of the worst case scenario. On the other hand, if the person searches for something and we really don't have this in our index because we don't have the product, it's probably fine. You still want to make sure that you properly deal with this. And this is one of the ways, for example, to continuously update synonyms. If people type things wrong all the way, right? And with the phones in our hands, like everyone fat fingers certain terms, so that like the meaning of a term just gets very different, and you need to track these and probably correct these. And if there's one term which gets typed very wrong, like it's often for brands, for example. I don't know if you have a brand like Zara or Desigual, like clothing brands. People just tend to write them very, very differently. Like they write them as they talk them or as they pronounce them, and that ends up in really wrong ways. But yeah, getting back to the measurement, like one of the things we usually tried to measure was always when search was involved, like how did this change the perception of the user? Did it change of users coming in from search? How high was the conversion rate compared to users which, for example, clicked on the newsletter? These kind of things. So you can at least compare it to other parts of your website. And the next part for the metrics is also the results that have been clicked. If a user searches for a certain term and it's always the fourth result in your result set that gets clicked, it basically means that something is not the way it probably should be with the scoring of your data, and if that is always the case. Or another thing is if users start paging deep, like if users take a look at the third, fourth, or fifth page of search results, this usually means that your first 100 search results are not the way they should be. And by just like pulling these things together, you can get a first impression of how good is your search, right? If you know that users always click on the first hit of the first page, it seems that you have a really good search, which often are the organic results, which basically means those are the results that are implicitly scored higher because you want to sell things, right? One of the parts of the scoring formula at my former company was the amount of money we made per product taken into account as well, because like it's an e-commerce site, you have to make money to pay bills. So if there are two products literally the same, but you earn more money on one of them, it makes a ton of them to score them higher. On the other hand, if they are not fully the same and you score them higher and people always click the other products, maybe you should rethink your strategy. So measuring the success is like only half of the equation here. You constantly need to kind of reiterate on these kind of things. Another thing is like landing pages were a big one. For example, if you search in the German language, something called pot, could be a cooking pot or a flower pot. And what does the user mean? It's really hard to tell. And at some point we had to decide, okay, for this specific e-commerce shop, it's always a cooking pot because this is where we make more money. So we we offer a dedicated landing page for this if the user searches for this instead of showing products, because we want to be sure that we always show the right product. So at some point, things also are not solvable by search anymore. Unless you really change your search deeply. And this is also something to keep in mind. There will always be special cases where you want to make sure that you really display the products you have in the form you want. So that sometimes the search is not enough, but you want to have this one fancy page or add another wizard where you tell the user, like, I think you wanted to search for this. Maybe you want to select those criteria. And changing the search experience is something that is really important. Search as you type is another really common use case for this. Whereas this is one of the few possibilities where you can change what the user actually wants before he has finished typing it, before he's executed the search. And that's very rare nowadays. And this is a way where I can tell the user, maybe you want to have this instead of that if the completion is already really, really good. But at our use case at my former company, we figured out that there are lots of people who only watch the keyboard when they type. So getting in all the suggestions was basically useless. Then we figured out another test with another target group, and they did everything right that we wanted to. So again, it's something you just have to test out. And this is another thing I can just tell people, like, don't make assumptions about how other people use your search engine, but have a bunch of testers and testing groups where you can validate your assumptions against. I think this is one of the most important, not a metric, but ways to go to really measure the success if your site search is working or not. And this for me was always the most important part, where we had those people come in and testing out the search engine, and you basically broke down because all the work you did was useless. but that's fine, right? Like you have to adapt how your users are using your search.
Did you answer the question number 5? What is a search engine? What is search for you? I mean, yeah, that was super interesting to cover all the cool use cases that you can have on an e-commerce website, and that resonates to me like the first initial question that we have for this session. What is search for you? I want to add just something because I mentioned before that we have the app search tool. And in App Search, we are going to collect most of the information that Alex mentioned. Like we are going to track things like if you have no hits when you are running a search query, for example, then you will have a report for that. And you will be able to fix on the fly the mapping, add synonyms if you wish, for example, for a given term, for example, because you are not finding the information, because there is, I don't know, something which is not covered by the implementation yet. So App Search can really help you on that. And also it will help you to change the ranking. And for example, if you want to make sure that people see a given set of products when they search for XYZ, then you can just move manually the items you want to put on the first position in the result set, like maybe the elements where you are making the money, the more money, as Alex mentioned. So you have all that implemented in App Search. That's why it's running and it's adding more feature on top of Elasticsearch. Otherwise, you have to implement all that by yourself.
So one good part that I found in this entire Elasticsearch when I started using it is like not just using it for search, but you can simply extend it to do analytics around the data that is being generated, right? Which is quite natural. You can simply extend, pull out your metrics and calculate something like GMV values, right? How much is the product value, sales numbers. So all of these are very natural, and you can take the data to Kibana and like start doing your regular analysis. So that is a very useful feature to me. And also you could like Elasticsearch has a lot of features that that helps you to do a lot of things. Like audit log is one such thing that you can audit all of these and like collect all the queries. Yeah, many things actually. Yeah. So, but in the interest of time, I think we are already 2 minutes past the session time. So it's been really a great morning. I think we had a ton of discussions around a lot of these questions and interesting topics. But of course, thanks for joining, and we'll end the session now. But if you have any questions, please fill in the form. We would take this question. We would do this session definitely once more, perhaps maybe 1 month down the lane or probably sometime again. So please let us know what you want to hear. So that helps us to do more of these stuff. Thank you for joining.
Thank you so much.
Thanks, Alex and David, in joining very early.
Yeah.
Sure thing. Bye there.
Bye.
Bye-bye.